Today's class is going to be centered on the cosine rule. The cosine rule is used to solve the unknown in triangles, especially when two sides and an angle between them is given. And the second application of the cosine rule is when the three sides are all given. So when we are faced with this kind of problem, then we would retire to the cosine rule. Now, the cosine rule is stated as follows: a squared equals b squared plus c squared minus 2bc cos a. Then call this equation 1, and we can have b squared equals a squared plus c squared minus 2ac cos b. Call this equation 2. We can also have c squared equals a squared plus b squared minus 2ab cos c. So these are the three formulas or the three equations we can use to solve for unknown variables. Of course, now I'm sure you know what a, b, and c represent. Now let us consider an example to show the application of the sign of the cosine rule. So example. Now consider that we are asked to find the angles of the triangles with the following sides: A equals 12 meters, B equals 11 meters, and C equals 9 meters. Now the three sides are given, so we are asked to find the angles A, B, and C from equation 1. We have a squared equals b squared plus c squared minus 2bc cos a. Now we have the three sides given, so we can substitute for them in this equation. In this equation, then we would have to collect the like terms and solve for our angle A. So we have that we have 12 squared equals 11 squared plus 9 squared minus 2 times 11 times 9 cos A. Therefore, we can simplify this further to be cos A equal to 11 squared plus 9 squared minus 12 squared all over 2 times 11 times 9. Therefore, if we simplify this further, we have that cos A is equal to 58 all over 196, which is equal to 0.2929. And if we want to make A stand alone, so A will be equal to the cos inverse or the arc cos of 0.2929, and A will give us 72 degrees and 58 bar. Is that okay? So this is the angle A. We can carry out the same step for angle B. Therefore, from equation 2, we have that b squared equals a squared plus c squared minus 2ac cos b. These equations has already been proven, so we won't bother ourselves with the proving or how these equations were derived. Is that okay? So we won't bother ourselves with that. All what we just need to know is that our b squared equals a squared plus c squared minus 2ac cos b, and we're going to substitute our values inside. If we do that, we have that our b, which is equal to 11 squared equals 12 squared plus 9 squared minus 2 times 12 times 9 cos B. And of course, cos B equals 12 squared plus 9 squared minus 11 squared all over 2 times 12 times 9. Then cos B will be equal to 104 over 216 if you calculate it very well. Then 104 over 216 will give us 0.4815. Then just like we did in the case of A, B will be equal to the cos inverse of 0.4815. And if you punch this in your calculators, you'll realize that your angle B is equal to 61 degrees 113 bar. So this is our angle B. Then we can either solve for C in two ways. The first method, we can either solve for C in two ways. The first method is a very simple method, which is, remember, our triangle looks like this. Let's call this our A, let's call this B, and let's call this C. So we have our A to be 72 degrees 58 bar, then we have B to be 61 degrees 13 bar. Then angle C is simply, since we know that the sum of angles in a triangle is equal to 180 degrees, therefore, since we know that the sum of angles in a triangle is equal to A plus B plus C, okay, angles A plus B plus C, this is angle C, plus angle C is equal to 180 degrees, which is the sum of angles in a triangle. Therefore, we have degrees 58 bar Therefore, we have 72 degrees 58 bar plus 61 degrees 13 bar plus angle C equals 180 degrees. This 61 degrees 13 bar is also the same thing as 61.13 degrees. Okay, so don't confuse yourself. So we have angle C equals 180 degrees minus, if you add the two together, if you have these two together, you have 134, then degrees 11 bar. Then angle C will give us 45 degrees 49 bar. So that is our angle C. Then we can also use another method. The second method is the normal method, which is C squared equals A squared plus B squared minus 2AB cos C. Is that okay? Now our C is equal to 9. So we have 9 squared equals 12 squared plus 11 squared minus 2 times 12 times 11 cos C. And if you solve further, we'll have that cos C will give us 12 squared plus 11 squared minus 9 squared all over 2 into 12 times 11. And this automatically gives us 184 over 264. Therefore, cos C equals 0.6970. Now, to make C stand alone, this will be cos inverse of 0.6970. And finally, C will give us 45 degrees 49 bar. So, we've been able to solve for the individual angles from what we were given. So with this, we have come to the end of the class on the cosine rule. Before I leave, Before I leave, I would like to give you 1 or 2 exercises for you to solve. Then you send your answers across to me. So let's call this class activity.